Hello all, I am Dr. Rizvi and this is part 2 of our video on shear force and bending moment. And in this video we will discuss types of supports and types of loads that act on the beam. So let us start with types of supports. So there are basically four types of support providing support to the beam. The first one is simple support. In this, the beam is freely held over a support. The free end is freely held over the support. This is simple support. This is the beam. The beam can move in x direction. The beam can move upward. The beam can rotate about this support, but the beam has a restriction in downward direction. So any restriction to the beam will provide a reaction in opposite direction. So it will face a reaction R at its free end. So simple support provide only one reaction and that is in y direction. The second type of support is roller support. This is also similar to simple support. In this, the beam is supported by a roller that is placed on some floor, and in this too the beam can move in x direction. The beam can move upward, the beam can rotate, but have a restriction in downward direction. So here also the beam will have only one reaction in upward direction. The third type of support is hinge support. Hinge support. In this support, the beam is hinged at a point like this. The beam can rotate about this hinge, but it cannot move in x direction, it cannot move in y direction. So it will face two reactions, one in y direction and one in x direction. This is the free end of the beam facing two reactions. So hinge support is having two reactions, one in x axis and the other one in y axis. The fourth type of support is fixed support that we see in cantilever beam like this. Now when the beam is fixed, so it cannot move in x direction, it cannot move in y direction, and it cannot rotate. So these type of beam will have three reactions, two of the axis x and y and third for the moment. So we will draw the free body diagram like this: ry, rx and a moment m. Three reactions are observed in fixed support. We will now move to our second section of this video, that is types of loads. There are three types of load faced by the beam. The first one is types of loads. First one is point load or concentrated load. Let this be a simply supported beam with the reactions R1 and R2 at free ends. This load, that is W shown here, is acting at a point. This type of load is known as point load or concentrated load, that is concentrated at a particular point. The second type of load is uniformly distributed load or in short form we write it as UDL. UDL, uniformly distributed load. It can look like this in the figures, and basically represented as W Newton per meter. For example, this length is L, and it is sometimes also represented as like this, W Newton per meter. So it can be represented like this or this. Both are correct ways to represent UDL. And for this, when we draw the free body diagram, this is the reaction R1, this is the reaction R2. These type of load act in the middle of the length over which they are acting, that is L by 2 and L by 2, and the total load will be W into the total span on which it is acting, W into L, this W into the total length. The third type of load is uniformly varying load. This load varies throughout its length uniformly. It is triangular shape load. It is represented, it is also denoted as UVL, and you can see on the diagram like this, triangular shape, or like this. And they are represented as W Newton per meter, same as that in the case of UDL. Their free body diagrams are made like this. The center of gravity for triangular section is at 1/3 distance from thick end. If this length is L, so this will be L by 3, and 2/3 length from thin end. Total load will act here at the center of gravity, and the total load will be equal to the area of the triangle, that is half base is L into height is W. So total load will be, total load for UVL will be half into W into L. L is the total span on which the UVL is acting. Similarly for this diagram, the load, total load will act here if this length is L. So from thick end it will act at 1/3 distance, and from thin end it will act at 2L by 3 distance. These two things you have to remember while you are representing the total load of UVL. So in this video we have discussed the type of support and types of load. Thank you.